Hey guys, welcome to the second lesson of chapter 6. This lesson is all about the properties of logs. It goes along a lot with the properties of exponents. So I'll show you that in, I think, the third slide. So we're going to start with a little bit of review from last class, solving for exponential equations. So that's when x is in the exponent, like that. So first, in this problem, we are not able, or Marta's not able to calculate log base 2 of 30, since her calculator doesn't have a key for base 2. That's a lot like most calculators, except for Desmos and our school calculators. So like this one that I have at home doesn't do a base of 2, it only does a base of 10. And then your phone calculators, they don't do a base of 2, they only do a base of 10, just a regular log. So we're going to estimate what log base 2 of 30 is going to be, and that's going to help us make sure that we get the right answer when we solve for x. All right. So log base 2 of 30 equals something. We're not sure. We can change this to an exponential function to make it a little bit easier to think about. So the base would be 2. We don't need the log anymore. The exponent is whatever the output was, and it needs to equal 30. So 2 to what power equals 30? That's hard to answer because there's no whole number that's going to give us 30. We could get really close. 2 to the power of about 5 would be 32. So we know that 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 times 2 would be 32. So that's 1, 2, 3, 4, 5 times that we multiplied 2 times itself. And so that's about 32. So we know that log base 2 of 30 might be about 5, maybe like 4.9. Somewhere around there, like 4.8, 4.9, somewhere pretty close to 5. So we already kind of changed this to an exponential function. 2 to the power of x instead of question mark equals 30. So we're going to solve this equation. Remember that if we have an x as our exponent of x, we need to undo it by doing log, because then we can move the x to the front. So we're going to log both sides of that equation, log of 2x and log of 30. Okay, so with the first one, we can use the power property to move the x to the front so that it looks like x times log of 2 equals, and then log of 30 stays the same. So now we can get x by itself by just dividing log of 2 on both sides. So if we divide log of 2 here, they cancel out, give you just 1x. And then when we divide log of 2 on this side, now I don't want you to make the mistake that this is log of 15. You have to actually input that in your calculator, like so. So I'm going to put log of 30, just like this. You guys can see that on your screen. Divided by log of 2, just like that. Press enter, and I got about 4.9. Okay, so our estimate was correct. X is about, and I'll make the squiggles instead, 4.9, since we're rounding to the nearest decimal place. All right. So in this next problem, we're talking about change of base. That's kind of what we did, or we discovered in that last problem. It's just kind of hard to see with all the work around it. So change of base formula is if you only have like your phone or a scientific calculator. So that would be like if I had log base 5 of 200, I can rewrite that by taking log of 200 divided by log of 5. Okay, so that's kind of what we did in that last problem. It was, I think, log base 2 of 30, and before we put in our calculator, we put log 30 divided by log 2 when we solved for x. That was our last step. So you see how the big number goes on top, the base goes on bottom. So that is the change of base formula. Okay, so that formula is if you have any base, like a, to any number, we can rewrite it as log of the input, b, divided by log of the base, a. Okay, so that's change of base formula. All right, and now we get to our product and quotient properties, our properties of logs. So we already talked about the power property. That's when you can move x to the front if you have it in the exponent place. So in these, we just have 2 logs being added or 2 logs being subtracted. Okay, so that goes along with our exponent properties. So if we had xa times xb, we could combine it to be just x to the power of a plus b. Okay, so that would be like if I had x squared times x3, we would add 2 plus 3 and it would be x to the power of 5. So that is going to go along with these. Remember, product means multiply. Answer to a multiplication question. All right, so when we add two exponents, when we combine them, we're going to multiply whatever's in the parentheses. So 5 and 6 are in the parentheses. So when I combine this, x is going to be 5 times 6, which is 30. Okay, so same thing with the next one. We have 5 and 2. They're both logs, so that's the same base. 5 times 2 is 10. So when we combine it, it'd be log of 10. Log of 10 plus log of 100. Multiply, since it's we're adding. 10 times 100 is 1,000. So we combine it, it would be log of 1,000. Okay, so no matter what number we have, a and b, or expressions, a and b, we combine it so that's a times b. All right, so in part C, we have subtraction. That's the quotient property. So quotient is the answer to a division problem. So when we have subtraction, we are going to divide the numbers inside of the logs to combine them. So it's a lot like the exponent quotient property. It's just backwards. So if we are dividing xb over xa, we can combine them to just be xb minus a. All right, so then we take that and we use it for logs. So log of 20 minus log of 5 would be log of 4, because 20 divided by 5 is 4. Log of 30 divided or minus log of 3 would be log of 10, because 30 divided by 3 is 10. Log of 5 minus log of 2 would be log of x, or 5 divided by 2, same as 2.5. So if we have log of b minus log of a, then we would combine it to be log of b over a. So it's always the first log over the second log, or the first number in the first log over the number in the second log. All right, so I have a few more log properties to practice with you. Just a few more things to think about. So in the first problem, log of 2, 3, log base 2 of 3 minus log base 2 of 5, since we have the same base, we can combine those. So it's going to combine. It's still going to be log with a base of 2. Since it's subtraction, that means that's the quotient property, so we are going to divide 3 divided by 5. And that's what it would simplify to. All right, and then part B, we have a base of 2 and a base of 3. We cannot combine these because they have different bases. So then in part C, we have log base 4, base 4. So we can combine these. These are going to become log base 4 of something. Since there is a plus in between, that's the product property. So we're going to multiply 5 times x is 5x. So that's what it combines to be, log base 4 of 5x. In part D, this one's a little different. We don't have 2 logs to add or subtract. We just have 1 log. Since there's a number in front, that means I can move it using the power property. So this is going to become u to the power of 6. So I can rewrite this as log base 3 of u to the power of 6. That's how I can rewrite that one. All right, so now putting multiple properties together instead of just one property at a time. In part C, I guess there's 2 parts C's. Oh well. So this is kind of like part E. So we have addition, we have subtraction. So we're going to use the product property and the quotient property. And if you notice, it's kind of hiding in there. There's an x in front of the middle log. So we're going to use the power property first to move this x to become m to the power of x first. So we're always going to use that power property first if we see it. So the left and the right logs just stay the same. So this is still log of k plus and then minus log of 5 at the end. And so I want to make sure all my bases are the same. So it's log, log, and log. All have a base of 10 since there is no number. So now I'm going to combine. I want to go left to right just like I would with simplifying expressions using the order of operations. So I'm going to start on the left side. So I'm going to add, which means I'm going to multiply what's inside of the logs. So this is going to become log of k times mx. I have to leave it just like that because I can't actually multiply those since they're variables. And then I have minus log of 5 at the end. So our final answer, we're going to finally combine these 2 logs. Since there's a minus sign, that means we're going to divide what's inside. All right, so this is going to become just a log of kmx over 5. And we want to just leave it like that since we can't simplify that fraction. And that would be our final answer. So all of that from the beginning simplifies to log of k times m to the power of x divided by 5. All right, and finally, we're going to do this one. I would normally just skip it, but this is a lot like what you have in your exit ticket for today's lesson. So we're going to do some of this together, but not all of it. I think we're going to skip the second and the last 2 rows. So in that first row, we have 1, 2, 3, 4 different missing pieces. So in this log properties puzzle, we are trying to match it up to the very first expression. So we're trying to match it up to be log base 3 of 60 if we combined the two logs that we are making. So what we are going to do is use the product property to find this missing piece. Log base 3 of 6 plus means that we need to multiply something inside of the log. So 6 times what would equal back to 60? It would be, should be 6 times 10. That one should be pretty easy. 6 times 10 we know equals 60. So this is log, the base should still be 3 of 10. All right, and then in this one we have log base 3 again, but there's a 3 inside the parentheses. So this time we're trying to figure out 3 times what number equals back. We're still trying to equal back to the 60 in the parentheses. This one might be a little bit more tricky to think of. You can always think of a shortcut. 60 divided by 3, put that in your calculator, you should get 20. So 3 times 20 equals 60. So this missing piece is log base 3 of 20. So log base 3 of 3 plus log base 3 of 20 equals log base 3 of 60. All right, and then we're going to go to the quotient property in the next two boxes. So we're trying to think of, again, we have 120. This time it's division because there's a subtraction sign. So we're trying to think of something. This is going to be a log base 3 of something. We want it to equal back to 60 still. So 120 divided by what equals 60? We should figure out that 120 divided by 2 equals 60. So 2 should go in the parentheses. All right, and this next one, we want to keep this log base 3, and we have to fill in the parentheses. So this one we have 240. So we're going to do it the same way. 240 divided by what equals 60? We should find that 240 divided by 4 equals 60. So our missing piece would be 4. Okay, in this next row, we're going backwards. If you see, we're given this time 2 logs that are being added together. So it's log base 6. So I know that in the very beginning, this is going to be a log base 6. And to figure out the missing parenthesis, all we need to do, since it's addition, is multiply the numbers in the parentheses. 9 times 2 is, that's right, 18. Okay, so then we could make up our own missing pieces here. So we could do maybe like a log base 6 of 6 plus log base 6 of 3. Since 6 times 3 equals 18. All right, and those are all the properties of logs. So you need to go into Schoology and complete this exit ticket. All right, bye.